Hello, this is Team 5's Project 2 demonstration. An example of a motivation for the development of this edge detection technology that we made in this project in a real-world setting is self-driving cars. Self-driving cars use RGB cameras to detect other vehicles on the road, street signs, and lone line markers. Self-driving cars capture images like the one on the left and use the edge detection to output the image on the right. This image makes it easier for the car to continue straight in a lane and avoid any obstacles. The edge detection technology needs to be fast and efficient, however, to allow cars to avoid accidents when traveling at high speeds on roads that have rapidly changing obstacles and conditions.
For our software design philosophy, we decided to modularize the code into user-defined functions in order to make it easier to write, to debug, and use and read. So our first function, input_I, gets the user input about the image, and then our gray function takes the color image and returns a grayscale image. The third and fourth functions, subimage and convolve, are used in the window operation, and we decided to break that up into two functions in order to make it easier to write and debug, because this was the most complicated part of our algorithm. The simp blur function performs the simple blurring algorithm on the image, and then Sobel does Sobel edge enhancement on the image. The thresholding performs the thresholding of the edge enhanced image based on the user input, and then edge detection rolls all of these functions into one in case someone wants to use our library but doesn't want to have to read through and understand every individual function. So our code is in two files. The first file contains all of these functions on their own as a library containing all of these modules, and then the second file is just contains the edge detection function being implemented so that we can run the program. And during this, we also outputted intermediate steps in each function. We outputted print statements to the console whenever each step was completed, and we outputted each saved image from grayscale to the blurring and edge enhanced images, all to a different file, all to separate files from the original in order to help with debugging, and also in case someone wants to use our library to perform things other than just simple edge detection, like if they wanted to do grayscale but not the rest of the functions. And then on the right, you can see the result of our function on the Purdue Arch image.
When running our program, the user will first have to input a correct file name and its image extension. For this test case, we'll be using the Leno test case with a PNG extension. The user will then have to input a threshold percentage value of how much of the grayscale will be cut out of the final edge detection process. For this test case, we'll be using 50%. Our function, in each function of our program, it outputs a print statement showing how far along the image process has gone through. Our function first converts the image to a grayscale. It will then blur the image, then calculate the gradient in both the X and Y direction, use that to enhance the edges, and then it will use the input of the thresholding value to figure out the output image. For a 50% thresholding value, this is the output for the image. Then we will run the test case again at a lower, for the same image at a lower thresholding value to visualize the difference. We'll use 15%. At 15% there will be more lines included in the final image due to the only 15% of the grayscale found in the image will be cut out. As you can see, the final image has more lines and more detail, is not as clean.
I'm going to showcase how our program handles errors. So this is going to be what happens when you don't enter a correct file name. You're going to get the outputted message, please enter a valid file name. This is going to be what happens when you don't enter an integer value for the thresholding percentage. You get the outputted message, please enter an integer for the threshold value. This is going to be what happens when you don't enter a value between 1 and 100 for the thresholding percentage. You're going to get the outputted message, please enter a value between 1 and 100.